Hello, I'm Dr. David George and I'm Director of Science here at Stockbridge Technology Centre. We do an awful lot of work at Stockbridge Technology Centre looking at how we can sustainably intensify production across a range of different crops. One of the key areas that I've worked on over my career is how we can actually start to introduce more diversity into our cropping systems, be that more plant diversity and for the various benefits that might have to making it harder for pests and diseases to proliferate in our monocultural systems, or be that more beneficial insect biodiversity, so how we can actually encourage things like parasitoid wasps, hoverflies, ladybirds that would actually give us natural biological control on our farms, in our crops. There are lots of different ways that we can look to introduce more plants into growing systems, and there are lots of different terms to describe them, things like companion planting, trap cropping. They're all generally grouped under polyculture. And a lot of my work, certainly early on in my career, was looking at whether these things could work on relatively small scales. And they do, and they can work very well. And in lots of other growing systems in other countries, we're using these sorts of methods. The problem that we have, or the challenge that we have in more westernized agricultural, horticultural systems, is how we can actually start to move away from monoculture, but to do that in a way that we can maintain yields and still be able to grow high quality crops that are easy to harvest, easy to process. One of the ways that we're looking to overcome those challenges is with this piece of kit here. We're working primarily at the moment in cereal crops with it, and it's something called a strip till. And what it actually allows us to do is go through any kind of green cover. It could be a football field, for example, and actually plant crops in strips where we've cultivated through, but also leaving strips of green cover in that crop at the same time. We've actually linked this machine to all of our precision agriculture technology here at STC, so that when we do that, we can do it with sub-inch accuracy, and we can go back year on year and farm effectively 50% of our field in strips, leaving the other 50% as green cover. The crop that we use, or the plant that we use for that green cover at the moment, is white clover. And the reason we're using white clover is that we can get lots and lots of benefits from it. It will start to diversify the system away from a monoculture, which will give us a level of pest control, because it becomes harder then for the pest to find the crop. It becomes easier for the pest to lose the crop if it does find it, if it falls onto the clover, for example. But it would also give us lots of other returns, things like nitrogen, being a leguminous crop. Because it's there all year, almost a permanent cover crop if you like, it will also give us protection from the elements. So in terms of managing soil erosion, we've got green cover over that crop all over the winter. It's a flowering crop, and we find that when we harvest our main crop, the clover will burst into flower into the autumn, which is great for feeding bees, not necessarily so good for some of those other beneficial insects that we want to encourage. Though in the longer term, we will look to develop seed mixes that will add extra things to the clover, as we've done with flowering field margins in the past, so that we get a more multifunctional seed mix that we can use with our main crops. One of the other uses that we have for non-crop companion plants at the moment is discovering new chemistry. A lot of crops that we've used in the past as pure companion crops tend to contain chemicals that are either quite repellent to pest insects, or can actually be taken up by the plant next door to change the way it smells to them and make it harder for pests to actually find that plant. We're looking at ways that we can use those whole plants at the moment, certainly in protected systems, but they also give us an interesting avenue for discovery of new botanically based biopesticides. And one of the glasshouses that I have behind me has actually been designed and built by the Crop Health and Protection Centre to be very flexible and allow us to screen lots of these new biopesticide products that are coming through. Botanical products are particularly interesting because they give us something that we can treat a crop with in much the same way that we use conventional plant protection products, but they're very, very compatible with integrated pest management. Botanical products tend to be very short-lived in terms of their efficacy, their toxicity against the insects that are on the plant, which in some ways is a downside. It means that we really have to make sure we get good coverage when we use them to have an effect on the pest. But it also means that we can come in quite quickly after we've used a lot of botanical products and start reintroducing biological control organisms as well, something that we now do regularly under glass for pest control. Because of the way some botanicals work, where we actually have root exudates being taken up by the plant next door, it does mean that we might be able to find some exciting products where we could actually deliver them through irrigation systems, which where we're producing hydroponically could be very interesting. Although so far we've been looking at this piece of machinery as being able to allow us to deliver and achieve high yielding polyculture within fields, we're also looking at it as a potential means to quickly and reliably establish flowering field margins. Because this particular strip till is high powered and has been designed for heavy soils, we think we could actually take it through grass margins alongside areas of field, or through old flowering margins that may have degraded, and refresh them. The really interesting thing for me at the moment, I guess a lot of my past work, I've always been looking at how we can introduce biodiversity for benefits to pest control and other elements of production. But it's only really now when we start to combine those agroecological principles with machinery like this that I can actually start to see how there could be a way that we can introduce additional plants to a system, a way that we could improve rapid establishment for flowering field margins in a manner that's farmer friendly and farm friendly. And we're certainly seeing so far with this piece of kit, we have a lot of interest from the industry, and we actually have farmers out trialling it in things like oilseed rape that are reporting very good results from it. So I'm very hopeful that with the marriage of ecology and machinery and engineering, we'll really start to see improvements in the way that we can truly sustainably intensify agriculture and production going forward.